Hello guys, today I'm going to do a presentation for regular expression and NFA versus DFA conversion. My name is Jiang. This is my email address, and this is for CS520 Presentation2 Topic 3. In this presentation, we're going to define the regular expression, especially for the case I'm working on, the A star or B. And then we're going to compare the deterministic finite automaton versus the non-deterministic finite automaton, which is the DFA and NFA. And last, we're going to do a conversion for the case I'm working on to DFA and NFA. So regular expression, they're just like algebra. It describes the same kinds of patterns that can be read by automata. It has a couple components. The first one is a symbol. In this case, we have A and B. And the second one is concatenation. That means the symbol has to be next to each other. And we have the union, which is the vertical bar. It means or in this case. And the last one is the star. We call that clean star. So the star can be any number, like from 0 and to a large number. I mean, it has to be a positive integer here. So the order for the operation is from, firstly, you go for a star, then the vertical bar, and then the concatenation. And you can also use parentheses as well. And all regular expressions, they are all DFA, which we are going to cover in the next couple slides. In this case, we have A star or B because we have the vertical bar here. So that means you can either pick the left-hand side or the right-hand side. So A star, that means you can have any numbers of A. You can have no A's, that means it's an empty string. You can pick just one A or 3 A's as well. And if you pick the right-hand side, then you only can pick one B. So that's the only state can be accepted. However, if you have A, B, that means you are not satisfied this expression, so you will be rejected, same as AAAB, or you have 2B, and if you have BA, and that's also be rejected. In a DFA has 5 elements. You have the finite set of state, finite set of symbols called the alphabet, and the set of transition between the states. And you have the start state and also the final state. And there's only one transition from one state to another state. And also the DFA is set to be accepted if the input exit at the accept state. So for example, here you have a double circle here. Q2 is the state which will be accepted. And we're going to do a sample run here, 001100. So we start from Q1, the first state, and for the first 2 0, you are going to loop at the same state, and the 1 you are going to jump to the next state, which is Q2, and another one, then you are going to loop at Q2. 0, you're going to the Q3 state, and the last one 0, so you're going back to Q2, and you are going to be accepted because Q2 is the final state. For NFA is a multiple transition out of a state using the same symbol. It can take multiple paths concurrently. It uses the epsilon transition or the empty character. It accepts the input if the last state is an accept state. In general, it's easier to construct NFA than DFA because NFA is more like the way a human think. And all NFA can be converted to DFA. So let's look at the example down here. We're doing the sample one, AB. So from the star state, so you have 2 choices for A because you can go multiple transition from one state to another. And then if you go to the top here, you can go B and Q3, another A, go to Q4, and B back to Q1. So Q1 is the accept state. But if you choose the bottom path, you go to Q2 and B, Q5, A, Q2, and B back to Q5. Q5 is a reject state. So because since Q1 is accepted, so that means the entire NFA is accepted. And here in this example, you can have a epsilon transition, so which means like you skip this, so you form a Q0 to Q1, and then you do A, B, so back to a Q1. If you pick the bottom path, so you do A, B, A, then you have no other place to go. So that means the bottom one is rejected, but the top one it's accepted. So that means the entire NFA is accepted. So let's convert the regular expression that I'm working on to the DFA. So the tool I'm using is from the CS520 class. And first of all, I'm going to assign the two symbol A and B, and then I'm going to put all the states in this DFA. So I have 4 states, and the starting state is Q0, and the accept state is Q0, Q1, and Q2. So let's do a sample run, A. So from Q0, the first A will bring you up to Q1. And then the second, third, and fourth A will just keep looping at the current state, which is Q1, and the end will be accepted. And let's do another one, which is AAB. So Q0A will go to Q1, and another A will just loop. B will go to the rejected state, which is Q3 here. And next one is B. So from Q0, if you go to B, you go down. So you have Q2, and that's it. So you are accepted. And BA, which is B will go down, and you have A, and you will just be rejected at Q3. And the last one is the empty stream. So since you have nothing, so you just stay in the start state Q0, and that will still be accepted. Now we are going to do the NFA. Again, for NFA, you can have multiple paths. From the beginning, you can either go up or down using the epsilon transition. And let's do the sample run here. So if we do AAA, so we'll go up to from 0 to 1, then go down to 2. And because 2 to 3 it's the A here, so you're going to do 4 times because you have 4 A's. So at the end, you end up at 3, and you will use the epsilon transition from 3 to 4, then 7. So you'll be accepted at 7. AAB, again, we're going to up, and then from 1 to 2, then to 3, you have A, look back to 2, and do another A, you have 3, and 3, then you have nowhere to go to B, because AAB it's going to be rejected. So that's why so you're going to end up at a rejected state. And we're going to do B. We're going down from 0 to 5 through the epsilon. Then 5 to 6 it's a B. And B, and that's it. And you can just skip using the epsilon to 7 to be accepted, because B it's going to be accepted in this expression. We do BA. Again, we're going down. We'll pick B, and 5, 6 using B. Then because 6, there's no way to from 6 to get to using A to get to any other state. So 6 will be rejected. And the last one is the empty stream, which is it's a little bit interesting. Like from 0, you're going to just keep skipping from 0 to 1, then using the upper epsilon to just bypass the entire thing here, and from 1 to 4, then keep skipping and to 7, and you'll be accepted. So that concludes my presentation, and I hope you guys have learned something from this video. Here are the reference I use: the NFA generator, the FA generator, and I also use the class notes from CS520. Thank you very much.